One of the questions I get asked the most is, what is data structures and algorithm? How do I get started with data structures and algorithm? And basically a roadmap to studying data structures and algorithm. So I thought to make a video explaining what data structures and algorithm is. If you are new to the concept of data structures and algorithm, or DSA as I would refer to data structures and algorithm in this video, then this is the video to watch. If you are new here, do subscribe. If at the end of the video you found this video helpful, please give it a like to help the algorithm basically. And at the end of this video, you will understand data structures and algorithms. We would split both words, that phrase, into their individual components as data structures and algorithms, and explain what it means. You would also understand why you should care about this and a step-by-step guide to effectively studying DSA. Though if you are already watching this video, then you know why you should care about data structures and algorithm, but we'll still help you with some reasons why you should care basically. And this video is for you. Is this video for? It's for you if you are a coder, you are a programmer at any level, and you are curious about what data structure and algorithm is, or what I have to say about it. If you're an aspiring coder, you are planning to venture into the tech space, you are new to the tech space, and you've been hearing about the buzz around DSA, and you want to know what the buzz is about, you should definitely watch this video. And to tech enthusiasts and curious cats who just want to know what DSA is about, then you can also go ahead and watch this video. Now, what is data structures? Data structures simply means a way of storing data, right? If you already write code at any level, then you should use something called an array. An array is a data structure because you store data in an array. In computers, we have data elements. The computers is basically manipulation of data, manipulation of information, and information is basically collections of data, right? Now, those data, where are they stored? Now, the structures where they are stored, the locations where they are stored are called data structures. And we have numerous types of data structures. Well, not numerous, but we have quite a number of them. And examples include arrays. Arrays is a data structure, linked list, queues, stacks, trees. All these things, they are data structures. They are ways by which we access and work with data in a system. Now, what are the types of data structures? This is just for your knowledge. It is not a question you'll be asked in any sort of professional setting that I've seen so far, but it's just good for you to really understand. You can know, it is enough for you to know the data structures that are available. We have arrays, linked lists, stacks, queues, trees. There are different type of trees. The common trees, binary tree, there's tries, there's heaps, and there's graphs. Those are the data structures that we have. But these data structures can further be divided into types: linear and non-linear data structure. Linear just mean like a straight line, kind of like a contiguous setting, and I have an image to show you what a linear structure is. There's like an order to it, and non-linear just means that an haphazard structure, right, is not straightforward. And when you look at the example of non-linear data structure, you're saying things like trees. You might not be familiar with tries or heaps or graphs at this point, but at least you know what trees are. You've seen trees at some point, and you know the way trees are with its leaves, and everything is this kind of shape basically. So graphs are also like this. If you are familiar or remember graph structure from math class, tries and heaps are also like this. They are non-linear data structure. But when we talk about stacks, we talk about arrays, we talk about queues, we talked about linked lists, they are linear data structures. So we have data structures for storing data, but these data structures are further broken down into different types, right? Array, linear and non-linear. And under linear and non-linear, we have the examples of data structures. Now, I gave some practical applications of linear data structures and nonlinear data structures. At this point, you might not really find it useful because you don't know what a stack is. So, why would you care about its practical applications? But I will link this slide in the description so that as you get familiar with it, as you start working with it, it might be helpful to come back to what are the practical applications of this. It really helps to cement some of this knowledge. One of the dare say one of the bad reps that I get is that um it is not the tools that um software developers get to use on a day-to-day basis. Most times when you are building websites, you are building with the client side, the server side, you are building with the mobile or whatever it is, or data science. You are not working with queues and linked lists, and so why do you have to know these things? But when you think of the practical applications of these data structures, you come to appreciate their knowledge. For instance, arrays are used in image processing, speech processing, even the screen you are currently viewing. The pixels are used. Arrays are used in the building, as a building block for this screen, right? When we talk about stacks, we use it in some algorithms, we use it in functions. If you write code, you know what functions are. When you talk about queue data structure, when you look at website traffic, we use queue data structure. Our playlist, our music playlist, they use queues. When you look at linked list, I'm currently moving front back, I'm navigating to and fro. This is the function of a linked list in a computer system being implemented. So the knowledge of all these data structures can be so powerful, though they are abstract because we don't get to use them all of the time. But you get to see how important they are in the low level grassroots stuff. They are the building block of our computer science knowledge, and even all of these languages that we use, that we are using, all these frameworks and stuffs, they have the knowledge of all these data structures. It is what has helped the engineers be able to build them. And again, I'm just going to link this so you can read it at your own time. But we have graphs here. Graphs is used in Google Maps, your Facebook friend suggestion. I know most of us don't use Facebook anymore, but Facebook friend suggestion uses the graph data structure. I think even LinkedIn connection suggestion uses the graph data structure under the hood, right? Now that's all there is about data structures. It's basically a way of storing data, and we've gone over the types and examples of data structures that we have. Now, what are algorithms? Since data structures are in a nutshell a way of storing data, algorithms just refer to the way that we solve a problem, the step-by-step approach you solve a problem. For instance, let's say right now you are hungry. What do you do first? If you are sitting on your bed, you get them from your bed, you go to the kitchen, you make some toast. Now you can further break that toast down. Like, make a toast is a pretty broad process. What is the process of making a toast? Bring out your bread, bring out your mayonnaise, bring out your eggs, bring out your whatever it is that you use, right? And combine those ingredients together. The step-by-step process of solving a problem is called an algorithm. Now, this does not just refer to a code. When you are cooking, making a recipe, even right now that I'm talking, the process of reading this, writing this down step by step is an algorithm. But of course, in the context of data structures and algorithms, these algorithms will translate to code, right? Algorithms also refers to all of the ways that we manipulate the data stored in our data structures. For instance, let's say we have our arrays. If you're already a coder, we have an array. If you want to you want to find an element in an array, right? The process of finding elements in an array is called traversals, like you're looping through an array. That is an algorithm, right? One of the practical applications of an array is a contact on your phone, your phone contact list, right? Now, when you want to search for a contact, you are looping through. Under the hood is called looping through all of the contacts to find the specific contacts you are looking for. Now, that is an algorithm. All right. Now there are numerous algorithm techniques. There is brute force, divide and conquer, dynamic programming, greedy algorithm, Cardano algorithm, two pointers, and all of these things. I do not think that you have to cram or go out of your way to learn all of these algorithms. When you start to solve problems, you would naturally see the use of these algorithms and it will just stick better. If you go out of your way to start learning divide and conquer, sliding window without practically applying them to a problem, you might lose that knowledge. But when you see a problem, you try to solve it, and then you are unable to solve it, then you read up about how to solve it, and you see that the solution used a technique called sliding window. Now that is a tool belt, that is a skill added to your tool belt, right? That is how to learn algorithm. Now there are other algorithm techniques. I don't think that this list is exhaustible, but these are like basics that I have used in problems. Now why should you care about data structures and algorithms? So far it's been like all of these things, but you still don't understand why you should care about it. But I do think that if you are here up to this point, then you probably know why you should care about data structure and algorithm. You know that it is widely used in coding interviews in the tech world, especially the FANG or MANG. They care about coding interview, those type of thing. Competitive programming, you use it, the knowledge of data structures and algorithm, such as Google Kickstart and all those hackathons. You need the knowledge of data structures and algorithms, and some of these competitive programming have really cool prizes and employment and all of these things. Also, it helps you understand about the low level abstract workings of your computer system. When I talked about the practical applications of data structures and algorithms, I mentioned how some of them are using like functions under the hood, right? There are data structures that control your function calls, that control even switching off your computer and turning it on, all of these things. And the knowledge of data structures and algorithms helps you to really familiarize yourself with this low level abstract knowledge that you would otherwise not have known while working with your frameworks and your languages that abstract all of this knowledge for you. Also, I believe that knowledge of data structures and algorithm gives you an edge over every other developer, right? Because it takes a dedicated time of consistent practice to be comfortable with solving data structures and algorithm. And yeah, that knowledge is yours to keep. It is yours, right? I just feel like it has such a high rate on investment if you do give your time to studying data structures and algorithm. Also, I believe that it serves as a mental exercise for improved ability to solve problems. It's just like how it's been scientifically proven that when you are bilingual or multilingual, it expands your brain capacity. Solving data structures and algorithm has that same effect, and I believe that this is because it is like a puzzle. It's like riddles. If you solve puzzles and riddles, this is that sort of thing, like all those trick questions that are sort of annoying, but there is this immense satisfaction when you crack them, and then the knowledge is just yours to keep. Also, it just improves your problem solving abilities. Data structures and algorithm goes beyond just writing down the code. It wants you to understand what data structure to use in whatever scenario. For instance, let's say that you want to build a software, right? That is that wants to find the shortest path to your favorite restaurant. Now you have to think, what is the appropriate data structure to use to solve this problem? Array is all nice and good, but the study of data structures and algorithm will help you know that for this sort of problem, when you are dealing with a network of roads, graphs is more appropriate. Now data structures and algorithm gives you these tool belts to solve problems better, and finally you're like the cool kid on the block or whatever, right? So yeah, I think that this is why you should care about the knowledge of data structures and algorithm. Finally, this is my step-by-step guide to effective DSA study. The first thing is that you want to understand and code each data structure from scratch. I said that it is pointless trying to solve algorithm. When we went through the algorithm, I said that it is pointless trying to, Google divide and conquer, then cramming that approach, cramming by backtracking, cramming greedy algorithm. It doesn't work, right? But when it comes to data structures, I believe that not cramming, but you need to understand each data structure, understand its pros and cons. When is it appropriate to use a linked list? When is it appropriate to use a stack? When is it appropriate to use a queue? When is it appropriate to use a tree? When is it appropriate to use a trie, a heap, or a graph, right? After studying these data structures, right, you need to understand all of their workings. How can you add to an array? How can you remove from an array? How can you traverse, like loop through an array? And just few problems revolving around this. Go to the next one, linked list. How can you add, remove, create a linked list from scratch? How can you traverse a linked list? How can you find an element in a linked list? Move on to stack, move on to queues, move on to graphs, to trees, to heaps, and to tries, and code each data structure from scratch. I'm going to link a JavaScript book in the description below. It is how I learned how to code each data structure from scratch. It's how I learned how to code each data structure from scratch and how to perform all of these operations on them, adding, removing, traversal, and the basic operation that you can perform on an array, performing it on other data structures too. If you have any book recommendation or video recommendation, kindly let me know. It's also hard for me to find any resource that taught about how to code up all these data structures from scratch, and I hope to explore all of this on this channel, coding them from scratch. Now, this book was written in JavaScript, but it also helped me write it in Python. So I feel like if you understand how it is written in JavaScript, if you understand the thought processes of the author, then you'll be able to translate the code in the book to whatever language of your choice. But if you have any other resource that you would rather use, do use them and let me know. I'll be glad to link them in the description below. Now, after understanding the data structures, there are about 8 of them or so. After understanding, learning how to code them from scratch and be comfortable with them at your own pace, then I believe that it's time for you to start practicing algorithms or coding interview problems on sites like LeetCode and HackerRank. You've probably heard of these two, but I think there are others. No, I think there are definitely others, such as Code Wars, is it Codility, and others. Really, so you want to start practicing algorithms after understanding the data structures. And why I'm insisting that you understand data structures first before solving all of these coding interview problems is because when you see a problem, you need to know what data structure to properly use to approach this. If you see a linked list problem, like you get a problem to reverse a linked list, if you don't know what a linked list is, if you've not coded it from scratch, if you've not performed operation on it, there is no point trying to solve that problem, right? So you need to first understand this data structure. Now, after understanding data structure and practicing algorithm, the knowledge of algorithm will naturally flow to you. For instance, when you get a problem on an array and you use a brute force solution, but then you see that okay, it's not working out. After, of course, devoting a lot of time to trying to solve it yourself, and you are still unable to solve it yourself, then you can look up solutions on Google, and you can see that someone has written a nice medium article on this problem, and they use something called fast and slow pointer or two pointers or sliding window technique, and you learn how to do this, and that knowledge sticks with you. That is the best way to understand and practice algorithm. Also, I would suggest that you do not just go on LeetCode and start practicing all of the problems, or go to account and start practicing all of the problems, it can get really overwhelming. So I would suggest a site like needcode.io. I'm going to link it in the description below. Needcode.io, where basically the topics are already structured, and under each topic you can go from easy to hard, right? So there is array, there is linked list, there is stacks, there is queues, there is dynamic programming, there is basically all of the categories of data structures and algorithm problems. And then there are different difficulties. You can go from easy to medium to hard. It's a very good way to practice in a structured format. It helps you to exercise your, what's it called now, um, let's say you study array problems, you study two pointer problem, then you are familiar with the two pointer pattern. That muscle is strengthened, right? Rather than solving random problems and it's like all of this knowledge are not coming together and you are feeling overwhelmed. So I really suggest a platform like that. There are also other platforms like educative.io. I'll link it in the description below, right? Where you can study in a structured format to help you strengthen your pattern knowledge, right? On this channel we're also currently studying the Sean Prasad list. Sean Prasad is also a structured list of solving data structures and algorithm. It's already in a format where the first question, the second question, it builds off of the knowledge you've used, and the difficulty progresses so you don't feel overwhelmed. I believe that when you are starting, and this is the best way to solve data structures and algorithm. And then you can now, after you are comfortable with the structured practice, then you can start practicing randomly, because when you go for coding interviews, competitive programming, they are not going to tell you where the question is coming from. You will not know what pattern to use. So after being familiar, after solving enough question to become familiar with a pattern that you are so comfortable, then you can start solving question randomly, right? Where you don't know what pattern it is coming from. Because when you know that, okay, this is a dynamic programming question, you are confined within that walls and you start to think that, okay, I'll solve this in dynamic programming way. But when you get a random question, then you don't know what to do, and it's really forces you to think and all of that. But this can get overwhelming if you are not yet comfortable with data structures and algorithm. Take it at your pace, right? Don't feel so pressured, because it can get overwhelming. You feel so stupid if you're just starting out data structures and algorithm. It happens, it's normal. But like with most things, practice, 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 you get better and you get comfortable. Now the third step is and this actually deserves a video of its own, is when you start practicing problems, how do you attempt a problem? Because I believe that attempting a problem is key to even studying and retaining what you have studied. This is why most people will practice 700 to 300 questions and yet feel like they don't know anything. This is because the way you are practicing is wrong. How do you attempt a problem? And this is my three-step way of attempting a problem. First, you have to understand the problem. If you do not understand the problem, you are not going to be able to come up with a solution. Basically, if you don't understand the problem, how will you come up with a solution? Whatever solution you come up with is not going to solve the problem, because you don't understand the problem. So the first thing is you have to understand the problem, right? You need to really understand what the problem is requiring of you. Then you want to attempt a brute force. Now that you have understood the problem, what do you do? This is where I call like a conceptual overview. If you were not to write a single line of code, how will you solve the problem? If you are given a problem where they said, you know, this girl wants to eat a bucket of yogurt and she has 4 buckets of yogurt, 2 is going to expire soon. So she has to eat the one that will expire soon now, and she wants to eat the one that will expire at a later date later. So how will you solve the problem whereby the ones that are expiring at a earlier date, she eats those yogurts first? Now you want to understand, okay, what is this question asking of me? Okay, I want this person to, I want to write an algorithm basically that allows them to eat yogurt that is expiring faster, they eat that one first, and yogurt that is expiring later, they eat that one last, right? And you want to ask, okay, how will I solve this if I was not writing code? Just attempt a brute force. Then when you attempt a brute force, you can now start making your code more efficient, read other people's code and what they've written to better strengthen your code. And I'm just brushing over this point because, like I said, it deserves its own video to really understand how to attempt a problem. And we should even see a problem together where we attempt it, following all of the steps to attempting a problem. We understand the problem together, we attempt a brute force, we try to make our code efficient, and then we read other people's code. So basically, this is all. This is an intro to data structures and algorithm. Basically, what you need to know about data structure, what you need to know about algorithm. If you were confused, I hope that this video clears it up. And do consider subscribing and staying tuned, because I do plan to cover all of the different data structures and solving all of these. Right now we are solving problems that uses all of these algorithm techniques, but it's also important that we understand the data structures first. So I plan to make videos on those data structures and exploring the algorithms. And yeah, you can stay tuned for the Sean Prazat solution. I hope this video was helpful. Do give it a thumbs up if you found it helpful, and I'll see you in the next video. Bye.